Hi, my name is Vahan Davodian. I'm a physics experimentalist for 30 years, and today we are going to talk about nanotechnology, which is so important in our life. It is in every aspect in our life. So, Nanotechnologies by Vahan Davodian, physics experimentalist, and this is my email, vahandavodian@aol.com. Well, of course, this is not new technology, but lately I can see maybe last 20 years, it's a lot of, inventions and then especially in, medicine and some other things. And, it just changed our life. And in fact, this started with a great scientist, of course, you know him. His name is Richard Feynman. And he just laid the foundation for this technology because his insight was so good. He was a great physicist, and then he got Nobel Prize in physics, and he was so important. For this, technology. So this is the branch of science and engineering producing and everything at the nano scale. As the name implies, nano means 1 billion. If we're talking about 1 meter like this, it's a 1 millionth of 1 meter, or if you imagine 1 millimeters, it's 1 million of 1 millimeter and 1 billionth of 1 meter. And in fact, they are doing in an atomic and subatomic level. And overall, most atoms, they are like 1.5 or maximum, 2 nanometers, which is the billionth of 1 meter. And Mr. Richard Feynman, he did this in 1959. He said if we can manipulate the atoms, so the behavior of that new whatever we create is going to be entirely different. And he was absolutely right. And what he did, he just changed our world. I read this for you. Nanotechnologies, they exhibit different properties than the same substance at the larger scale. It means that, when we deal with them at the subatomic and atomic scale, it's entirely different. And in fact, I had some comparison here so you can visualize exactly how small 1 nanometer is. So we have a needle here. See, this eye is exactly 1 millimeter, and which is 1 millimeter is 1 billionth of this, scale. And here we have like a dust mite, which is micron. And then the human hair is 120 microns. And then the red cells, we got 8 microns. And then the DNA is 2.5 nanometer. And this is the important discovery. It's called the carbon nanotube, which just changed our life. And well, of course, I will explain later. And this is called the buckyball. He was the man, he just invented this, he came up with this idea, and, he revolutionized everything. And this is, let me show you, this is 0.0000001 nanometer. So in other words, this buckyball or this nanotube is 1.3 nanometer. And imagine how amazing it is. And here we have also DNA for the humans as 2.5 nanometers. Of course, Mr. Richard Feynman was so good in physics, and then he, like I said, he proposed this in 1965. Also, in 1981, he proposed something else for the computers, because if you remember, every 18 months we have a new generation of computers. And it means that, sometimes you cannot keep up with them. They have so many new generations, and every 18 months the computer is getting faster and faster. And his insight for that one was so good, and it's called quantum computer. As you know, when we're talking about physics, and then in a quantum level, everything is so different. It has nothing to do to the planetary level or the other things. Quantum is so small, and that's why Mr. Richard Feynman also talked about the computers, that one day they be so small, and he was absolutely right. I will explain in the next poster that how much advancement we made in computers, and is beyond my imagination. Let me get this down and then put another poster so you can see. This all started with a scanning tunneling microscope, which was the most important discovery of the 20th century, and that changed our life. And then these are two scientists from Germany and Switzerland, Heinrich Royer and Gerd Benning, and they invented this. And imagine, with this scanning tunneling microscope, it had never been done before, and then we can do the atoms, and like here you can see, this is the atoms of this cesium, and this 7 nanometer by 7 nanometer. And what it is, it's an amazing technology. You can see they have, well, of course, this is not showing everything, but this is the block diagram. But you can see this tip or the probe. And I mean, how could they do that? That tip is a tungsten, and how could they come up with 1 nanometer? Is exactly size of atom. Well, I'm sure they couldn't do it by hand or anything. This was done with laser, and this is called tunneling. So when we're talking about the nanoscale, everything changes. So this is so close to the probe, for the sample, and imagine this is magnified. See how big it is. Then this is almost touching, because the humans, we cannot see how small the nanometer is. But this is the way it is. And then this tip, or this probe, is almost touching the sample, and everything, well, of course, is amplified here, then goes to the computer, and then you can see. And this is, I mean, amazing technology. And this is the one. At this time I was in Denver, and then I noticed this, and this was called Bose-Einstein condensate. And this is the photos of rubidium atom by physicists Eric Cornell and also Carl Wyman. This was year 2000 at CU, and this was also amazing, and imagine, this is one atom, this is another one here. I mean, how could they do that? This is because of the scanning tunneling microscope. And I remember we were in Colorado at that time, and then it was close to us, like 7 miles. I used to go there. They had so many lectures in physics. Then I saw how difficult it was. They got almost close to the absolute zero, and both of them, they have Nobel Prize. At the same time, they have another one in MIT, Mr. Wolfgang. He also got, they shared the Nobel Prize. But imagine, this is the single atom. It could have been impossible 40 years ago, but like I said, in 1980, when they invented this scanning tunneling microscope, it changed everything. Well, of course, I have to mention also, we have electronic microscope. That magnification is not a lot, but this is something else. This is so, I mean, amazing, is beyond your imagination. Magnification is 100 million times. Even, electron microscope is not as good as the scanning tunneling microscope, but 1 million times. And imagine, you can see everything. So let me put another one. Yes. In fact, I have to explain how important carbon is in our life. And as you know, the carbon has three allotropes. So in other words, the molecules are formed that can be like a soot or charcoal, they can be like a graphite, and they can be like a diamond. So it depends on how they form. So now he was a good scientist. His name was they call him hockey ball, but you know his name was Richard Buckminster, and he was American, you know, architect. And then he came up with this nanotube, and then buckyball, which changed everything. And imagine this is so amazing in our life. Like this bike, you can see the entire bike is 1 kilogram. Nowadays, the bike is like 8, 9 kilograms, and imagine that is so strong. And the one amazing thing about this, you know, discovery with Mr. Buckminster is that you know that is 100 times stronger than steel. I mean, how could you have nanotubes that you can't even see? You have to use a scanning tunneling microscope to see that. So this is the tube, and it's like a graphite. You know, it's like a sheet, so you can roll it up. But this has been enlarged maybe millions times, and you see the way they are is like a tube, and that can be used in aerospace, they can be used in, you know, everything in sports, you know, make the racket for tennis, and then everything else. So this discovery was so important, and like I said, nowadays this nanotechnology is changing everything. We can see new cars, it's much lighter, more dependable, and they last longer. And the good thing about this, they won't rust. I mean, they last forever. So, and this bike was in 2005, and like I said, the whole thing is 1 kilogram. And this is the buckyball. This, well, of course, this has been enlarged God knows how many billion times. And then you can see this has 60 atoms, and it's like a hexagon. See, you can see the way the atoms are. And this was in 1985, and because his full name was Buckminster Fullerene, but they call it buckyball because it's so important. In, and in imagine when he invented this, we had 1,000 new chemicals, and these are so amazing. These chemicals, and one more thing. These are conducting electricity and also conducting heat. And imagine, carbon is so important in our life. It's a building block of everything. But now this is the fourth allotrope, which is called the Buckminster. And imagine, it changed everything. This is my favorite one. But I have to mention, where did this come from? Let me put this up for you, you can see it. In fact, this technology started with electronics. But I have to mention something important. I was 10 years old, and then my brother was a good technician, and then, you know, I was so good, you know, learning because he was 5 years older than me. Finally, he told me, Juan, if you want to have your own radio, I have to go downtown, get some transistor dials, and, you know, speakers and things like that, so you can do your own. I don't know. I remembered exact circumstances. I was 10 years old, so I gave him some money. So he went downtown. He bought me a transistor. He bought me a dial, and then a speaker and the battery and everything else. And imagine, I remember that transistor was exactly. Now I remember. I have the old ones. I don't know how could I kept those things. Those are exactly 12 millimeters. Now the same thing is 12 nanometer. Imagine in the 65 years how much we advanced in technology. In that 12 millimeter you can has trillions of transistors. Now you can see we have the, transistor, and this was breakthrough in science. And this is the first transistor. And imagine, I don't know the dimensions, but you can see how big it is. This is a plastic. Then you can see how big it is. Now the same thing was in 1947 in Bell Lab. We can have maybe trillions of transistors in the same space. And this was with John Bardeen, and he was amazing scientist, physicist, American physicist. And not one, he got two Nobel Prizes. And there was another one, they used to work together. His name was Walter Brattain. So they got Nobel Prize for this, and this was in 1947. But I remember when I was in almost like 10 years old, 12 years old, and then I could see the transistors. And at that time, there was no IC or there was no chip like this, but it was transistors all. And then the radios had like 6, 5, or 7 transistors. And imagine, I show you this evolution. I mean, how this happened. So imagine this is the 1930s, and imagine this is a huge computer, and this could occupy one room. And imagine those days we didn't have the transistors, so we had tubes. And even I remember the tubes, and then they were so slow, they would generate a lot of heat and so and so. But they had 17,468 valves or tubes, and imagine they weighed 30 tons. And this is another radio, and I remember this. And then finally came the transistors. These are in 1960s. But this is amazing. Intel is a good computer, you know that, and then I used to have that, the precision is so good, I mean, they last forever. So this is the IC from the Intel, and in 1971 this IC had only 2,300 transistors, and nowadays they have 2 billion. The reason why everything is miniaturized. I mean, how important it is to miniaturize. And nanotechnology, it implies the name miniaturization in an atomic level, which is so good. And imagine nowadays we have these ICs, which is called integrated circuits. And imagine 2 billion in one IC like this. And nowadays, imagine in so many years how much we advanced in technology. And this is the transistor I used to use. And like I said, these are exactly 12 millimeters. And it was 3, like this base, emitter, and collector. Well, of course, nowadays, they hardly use this. You can see once in a while they have ICs a lot. Once in a while they have one single diode or one single transistor. They, in a circuit. This is a Dutch scientist, which I just decided to display this because how could a merchant become a scientist? This never happened in a history of science. It never happened in a history of physics. And his name was Antoine Leeuwenhoek from Holland, and he was amazing. A lens maker, instrument maker, and this is his microscope. And can you believe a merchant become a scientist? And that is not end. What he did, he discovered the bacteria. Can you believe that? And then single-celled, like plants, single-cell animals, and everything else. And why they call him unassuming scientist? Because no one was expecting, a merchant from, Netherlands become a scientist. Because he was grinding lenses all day long, and he was amazing, precision person. And one good thing happened in his life, he was not accepted, but even though he did all these discoveries, and I'm guessing, even scanning tunneling microscope can do the same thing. And imagine this magnification is maybe 500,000 times more. And this is his microscope, and it was so simple, two lenses only. And one thing happened, he was so smart, unfortunately he couldn't speak any languages but Dutch, and finally he learned English, and then he had to go to England and then submit this to the Royal Institution. And at that time, Royal Institution was one of the most prestigious, science, organization in the world. And finally, he was so lucky, it was accepted. Then they recognized that, Mr. Leeuwenhoek's invention is legitimate, and, it worked. And nowadays, even you can see in some, science museum, you can see this microscope. And, it's just worth it mentioning that, this man was genius, and the way he did was so good. And nanotechnology has so much applications. Let me put this up, you can see. Of course, there's so many, but I have some of them. First of all, the lightweight body armor. They can put, you can have body armor for the law enforcement officers and everything else. So clear nanoscale films on eyeglasses, and then washable, durable, smart fabrics. So lightweight cars, airplanes, aerospace, nano bioengineering for enzyme, high power rechargeable battery. There will be a way that that you walk in the street and then your battery will be charged, and then you don't even have to come home and then plug it in a wall to get that charge. And use catalysis to boost chemical reactions, and then electrical and IT computers, and computers we showed you a few minutes ago, and transistors, which is the basic switches. And imagine without this nanotechnology or miniaturization, we would not be able to do anything. And imagine if we do anything for the space, and then it will take months and years for calculation, and the computers does that so fast. And then flexible, bendable, foldable, electronics. I have seen on YouTube, you can also watch it. Sometimes they're showing it's a plastic, and you don't even have to have that insulator, and then all those solders and everything. It is plastic, and then on top of the plastic we have like transistors, and you can fold it, you can stretch it, and that is amazing technology. So medical science, also medicine to improve the vaccine, also energy. And then I saw one documentary, and they can also sanitize, and then they can just improve the solar cells, so we can get more electricity. And in fact, there is a project in Saudi Arabia. I think it is $22 billion. So there's some scientists from United States. They're helping them. It's not like ordinary cells, so they can improve that for thousands of times. So imagine one day we don't even need the fossil fuel. This is another one. It's showing the applications. Let me just put this up. You can see. This is beyond my imagination. This is the DNA. Well, of course, this is, like I said, been enlarged maybe billions of times, millions of times. And then imagine they can manipulate your DNA also. because the reason why this is in nanoscale. And imagine how many things you can do is for the plants. You can do I read that energy, medicine, drugs, and then nano devices, and then optical engineering, and then in defense, in everything. Yes. And this is so shocking. You may be shocked. I tell you, there'll be a day that they can send these nano devices in your blood, and then you don't have to even do X-ray or anything, or MRI or anything. That goes everywhere and then checks. There's a problem here. It's exactly the way we do for the cars. We have a probe. We put it in cars. That plug in the in your car. It goes check everything that says this is a faulty component here, there's a faulty and there's a day that one day they will do that, but I'm not sure, maybe we're not going to be alive, but the nanotechnology is changing everything. And here you can see you can do it for the plants, you can do it for animals, insects, for everything. So I'm hoping one day I'm hoping one day this will take over our life, and then we won't have any problem with the cancer and everything else. And there's one more thing I like to mention. This is a good technology also called PET scan, positron emission tomography. And this is so amazing. And imagine in your body they inject like very low radioactive material. Then what happened? That is called positron, which is the exactly opposite side of electron, and that goes in that cell, that bad cell, cancerous cell. And what happened? It is annihilated with the electrons. And imagine this technology is so good. And we had a friend, he was explaining. Then I had to research a little bit, and this PET scan is going to change our world. It's amazing. In one nanoscale, they can annihilate positron and the electrons. But we heard that it can happen in space and so, but now they can do it on a human body. Well, of course, that procedure is extremely difficult. You have to have so many physicists on board so they can check everything and make sure everything is okay. So I'm hoping you guys like this video, and if you like it, you can subscribe it, and then also give me a thumbs up. And like I said, your encouragement is so good, and then that's why I'm always having these new technologies and everything else as much as I can. Maybe I'm not as good as those other people are doing, but I'm doing my best as much as I can, and I'm hoping you like this, and then you can subscribe it. And I'm hoping every 2 weeks I will have more and more new technologies, and then you guys can learn as much as possible. If you have any concern, if you have any questions, you can email me. I'll be happy to answer your questions, and I'm always ready, standing by, because I'm retired and my only hobby is the physics, and I'll be happy to help you guys. Thanks a lot for watching.